Hello and welcome back. We are going to continue our discussion on the 2021 BC exam. This is question number 2. And question number 2 is one of our particle motion or vector questions right here. And it says, for time greater than 0, a particle moves on the xy plane given the following position. The velocity vector is given below here. Now, since this is my velocity vector, we know that this is a derivative right here. And they give us the initial position at -2, 5. So since they give me the derivative and the initial position, I'm thinking FTC, that they're going to give us the fundamental theorem of calculus here. Question A, it says, find the speed of the particle at t equals 1.2, and then find the acceleration vector of the particle at t equals 1.2. So we're going to look at speed first. So to get speed, remember this is going to be just the square root of our first function squared. This is x prime of t, and if we call this y prime of t, if we plug this in, our speed equation, remember it's x prime of t squared plus y prime of t squared, the square root of that. And that's going to equal, if we type all this in, it's going to be 1.2 minus 1. Whoops, I'll use brackets. 1.2 minus 1 times e to the 1.2 squared, all of that squared. Ooh, that's ugly. Plus the sine, again parenthesis bracket, sine of 1.2 to the 1.25 squared. And the AP is not messing around this year about typing things in a calculator right here. And if you type that in your calculator, let's go ahead and do so. Here's my trusty calculator. So when I type this in, it's going to be the square root of, I type this in, open up a parenthesis here. I'm going to abbreviate that as 0.2 times, whoops, get rid of that, e to the 1.2 squared, square that, plus, open up another parenthesis, sine, it's kind of hard to see there, the sine, and let's see here, 1.25 to the, whoops, sorry, 1.2 to the 1.25, square that, and if I press enter, we should get our answer. Oh, there it is. We're going to go to 3 decimal places, 1.271. Oh, that is pretty nasty to type in. All right, the second part says, find the acceleration vector. Well, we know to get the acceleration vector, a of 1.2, it's going to be the second derivative, x double prime of 1.2, oops, weird looking 2 there, 1.2, y double prime of 1.2. Now, I don't have to take these derivatives, and honestly, I really don't want to. Product rule, chain rule, quote, I mean, it's just a nasty derivative, but I can use my calculator, and using the CAS makes it really easy. And again, if you have the CX, it's just as nice. Let's see if I can get this to show up a little bit better there. There we go. If I go menu, calculus, this time I'm looking for the derivative at a point. I'll use x. I'm looking for the value at 1.2. And I just have to type in my function. The first one, x minus 1 on the outside, times the, whoops, that's not that one. Where's my escape? There it is, escape. There we go. Times e to the, what is it? T squared, so to the x squared. And I press enter, and I get 6.247. So there's my change as my x. So it's going to give me 6.247. There we go. 47. And if you do the same thing for the y, doing a derivative, you should get 0.405. Now it does say a vector, so I did use my chevrons right there. Now, how much would this be worth? This question might be worth 3 points. Get a point for your speed equation in your answer, and just 1 point for your acceleration vector. This would be worth about 3 points, I would think. For part B, but don't quote me on that one. This is not the score. I don't have the scoring guidelines for this yet. Part B says, find the total distance that the particle travels over between 0 and 1.2. Well, that's just our integral, total distance from 0 to 1.2, the square root of x prime of t squared plus y prime of t squared dt. So this is going to become 0 to 1.2. Go big or go home. Ready? The AP is not playing around with this one. The parenthesis t minus 1, e to the t squared, squared, plus sine, big bracket, of t to the 1.25 squared dt. Alright, so let's go ahead and see if we can type this in here. Whew. Now you'll probably get a point already on the AP just for typing that all in, writing it all out. So this is getting kind of hard. Gotta get better technology here. Someday, right? Someday. Alright, so when I type this in, menu 4.3, we're going to go from 0 to 1.2, the square root of parenthesis, another parenthesis, x minus 1, I'm going to use x, times e to the x squared, squared, plus, open a parenthesis, we're committing a sin, sine to the x to the, 1.25, square that, and then don't forget your differential, the dx. Alright, let's see if this works. Yeah. Now, okay, so you see this little error right here? This is such a big problem for the calculator. It's having a hard time computing it. So this thing's saying, hey, look, we approximated really, really as good as we could, and this is what we can get. That's the answer. And this becomes 1.1, oops, sorry, can't round, 0, go to 3 decimal places, 0, 1, 0, or the AP might accept 1.0098. What they'll do, they tend to truncate at that 9 right there. But rounding is always good. Probably worth 2 points, 1 for setup, 1 point for your answer. Alright, so for part C, let's take a look here. Now here comes the FTC step. Find the coordinates of the point at which the particle is farthest to the left. Now I'm thinking candidates test right here. Explain why there's no point at which the particle is farthest to the right. We'll talk about that later. So I'm thinking candidates test here, and the reason I'm thinking candidates is because it says the farthest. My only problem is it doesn't give me endpoints. Remember, for a candidates test, you need your critical numbers and endpoints. But what happens if we don't have endpoints? Well, let's see what happens. So let's look for our critical numbers. We're only dealing when the particle is furthest left. So since I'm dealing with this further left, I'm only looking at the changes in x. I'm looking at only the change in x, not the change in y. So I want to find out where x prime of t equals 0. And that's going to give me t minus 1, e to the t squared equal to 0, and e to the t squared can never be 0, so we just get t equals 1. That kind of makes sense. Since there's no endpoints, I only have one candidate. So I want to make sure that this one candidate is indeed the furthest left, or in this case, it will be a minimum. So starting at 0, because t is greater than 0, there's 1. Here's x prime of t, and how does it make my function look? X of t, right there. So I'm going to check this, plugging this into my derivative. If I plug in something less than 1, like 0.5, this is going to give me negative and a positive, so this is negative. So that negative tells me we are going to the left. If I plug in something like, I don't know, 10, positive, positive, it's going up. So this is going, so here we're going to the left, and then afterwards we're only going to the right. So I know that the furthest left only can occur at t equals 1. So t equals 1 is the furthest left that it can go. And the reason for that is kind of simple. One, it's the only candidate, and the slope goes from, and the derivative, the change in x goes from negative to positive. So we go from left to right. So that's our furthest left we have to go. So now we have to get the point for this, okay? So to get the point, we need x of 1. And this is where our FTC comes into play. So that's going to go from 0 to 1, x prime of t dt equals x of 1 minus x of 0. Alright, so once I got this, I can type this in my calculator, and I did that for you. This becomes negative 0.604. So basically, if you integrate this integral right here from negative 1 to 0, we're going to get negative 0.604 equals x of 1, which is what we want, minus the initial x value. And remember, they told us that at the very beginning. My initial x value is negative 2. So this becomes a negative 2 here, and x1 becomes, if you add that, negative 2.604. And we're going to do the same thing for the y. y1 becomes this. 0 to 1, my y1, y prime of t dt equals y of 1 minus y of 0. And I'm going to type that in. We'll actually type this one in here. So I can go here, calculate menu for 3 from 0 to 1. Just to show you how this is. And if I go up here, there it is. It's this sine function right here. So it's going to be the sine of x to the 1.25 dx. And if you press enter, you get 0.410. And that's going to go down here. So this becomes 0.410 equals y of 1. And my initial y value, they told us, was 5. And we see that up here, 5. Alright, so we get y1 equals, and if you add this up, 5.410, and write your answer as a point, negative 2.604, 5.410, and there we go. Now we're not done with this. Now how much will this be worth? Probably 1 point here, 1 point for your setups, and then 1 point for your answer. But then they say, explain why there is no point at which the particle is furthest right after t is greater than, for t is greater than 0. Well, so real simple. There is no point furthest right because from 1 to infinity, the particle just keeps going to the right. So we can say there is no point further right. No point furthest right. Let's do some calculus stuff here. Because, so we can use some math language here. On the domain 1 to infinity, x prime of t is greater than 0. And let's explain what that means in English. Therefore, this just continues, we should say, therefore the particle, can't spell particle, don't tell you English teacher, therefore the particle continues to move to the right forever. On the domain 1 to infinity. That's what it means there. Alright, so that's not too bad to understand, but again, notice I use my sign chart. They're everywhere you want to be. I hope you enjoyed this video. Go to question number 3. We'll see you soon. Bye-bye.